Today we're going to be talking about 9.2 and 9.3 together. 9.2 is arithmetic sequences, which we are going to start by wanting to know a starting value and a common difference. So for this, if I have a sequence, say 2, 4, 6, 8, all the way to 100, our starting value is a, or a sub 1, and then our common difference, what it goes up by each time, will be 2, because we're going to add 2. Notice that's what arithmetic is going to be, is repetitive addition. So in this sense, my first value is a, so a sub 1 will be 2, and my common difference will also be 2. So we're going to look at two different types of formulas. One is recursive and one is explicit. With recursive, we need a previous term, and this will be used in some types of forms or definitions. They call them definitions or formulas, but in this case, the recursive definition uses our previous term, and then we add on our common difference. For explicit formulas, this is more like writing an equation. We take the number of terms that we want. Say we wanted the 20th term in a sequence, so I'm going to write a sub 20 will be equal to my first term plus the number of terms minus 1, so in this case 20 minus 1 times my common difference. So the big things that we really want to know is our starting term and our common difference. So we're going to try this. We're going to write a recursive formula. In this case, our recursive formula is built off of this idea of we start with 5, so a sub 1 is 5, and our common difference is going up by 3. So to write this formula, all we need to do is copy it. A sub n is equal to a sub n minus 1, the previous term, and then plus d. So big thing here is we're just going to rewrite this as a sub n is equal to a sub n minus 1 plus 3, and we're done. This is our recursive definition or recursive formula. Now we're going to write the explicit definition. In this case, again, a sub 1 is equal to a plus n minus 1 times d. So all I'm going to do is replace the first term with 5, and then n minus 1 times 3. This can also be rewritten as 5 plus 3 times n minus 1, or 3 times n minus 1 plus 5. However you want to think about it, it's perfectly fine. So to find term numbers, so in this case the 100th term, I'm not going to use the recursive definition because I don't know what a sub 99 is. Don't know what it is. But I do know the first term, and I do know the common difference. The first term is 5, the common difference is 3. So if I want a sub 100, I'm going to equal it to 5 plus 100 minus 1 times 3. So in this case here, I'm going to end up with 5 plus 297. And then I'm going to add it, and I'm going to end up with 302. 302. To find the 1000th term, I use a sub 100, and I'm going to have the same formula, 5 plus 1000 minus 1 times 3. So this is 5 plus 2,997, which will equal 3002. So you can kind of see what I'm doing here. I'm using the explicit formula to find missing terms or terms that I want to know. I can only use recursive if I know the previous term. It's useful for some things, but not for everything. So I want to know the 200th term of this. This is just going to be starting value of 6, and then my common difference will be 6 to 11 is 5. So a sub 200, my 200th term, is equal to 6 plus 200 minus 1 times 5. Well, 200 times 5 is 1,000. 1,000 minus a 5 will be 995. Add it to 6, and you should be getting 1,001. So finding missing terms is pretty easy as long as we know our first term and our common difference. So what happens if we don't know terms in between? So in this case, I want to know the second and the third terms of this arithmetic sequence. That means I need to look at 100 comma, dot, dot, 82. And I'm going to think about this. I have to have 3 common differences, so to get from 100 to 82. Now I like to think about it this way. 100 minus 82 is going to give me 18. So these two numbers are 18 spaces apart, and it's spaced out with 3 common differences. So now all I'll do is divide by 3, and my common difference here is going to be 6. So now, since this is going down, oh, I should have put it this way as well. The biggest thing here is I'm going from 100, so I should have done this backwards, my apologies. I'm going from 82, and I'm starting at 100, so future minus past, essentially, if you want to think about it that way, or start. And this will be negative 18. So our common difference is 6, so it's going down by 6 each time, and you can see that pattern. You didn't have to do the negative, but it helps in my mind thinking about it that way. So if I go down by 6 each time, this is going to be 94, then 88, then 82, and our pattern works out. So now we're going to switch gears. So if you need to, pause. You can rewatch from this point on. We're going to talk about geometric sequences, and you're going to notice the difference here. Geometric sequences are not going to be the repeated addition. They're going to have repeated multiplication. But again, we need 2 things. A starting value and a common ratio this time, not a common difference. So we're going to want to know what we multiply by each time. Again, we have this recursive formula, and the recursive formula will use our previous term times our ratio, our common ratio. Fact of the matter, though, is you have to have your previous term. So this one doesn't seem that useful unless you are of a different mindset. Then we have our explicit formula, which takes our first term times our common ratio raised to the n minus 1. Ooh, interesting. So we have this sequence here. I have 3, 6, 12, 24, 48. And each one of these is times 2, times 2, times 2. So in this situation here, if I want to write a recursive definition, I need to know my first term, which is 3. My ratio is 2 because I'm multiplying each time by 2. And so my recursive formula is the nth term is equal to the previous term before that times 2. I wish it was more difficult, but that's just exactly what it is. So now I want to write the explicit definition. Again, my first term is 3. My common ratio is 2. So in this case, if I want the nth term, I need to have my first ratio times, my first term times my ratio raised to the n minus 1. Again, notice how the n minus 1 doesn't change because I don't know what term I want. And so let's try a few with which terms that I want. I want the 10th term, so I want a sub 10 is equal to 3 times 2 to the 10 minus 1. That's just 3 times 2 to the 9th. So if we're looking at 3 times 2 to the 9th, you get out your calculator, and from there I would do 2 to the 9th first. That would be my first goal. And so on my calculator, I see that 2 to the power of 9 is going to give me 512. So this is really, this is really 3 times 512, which should give me 1,536. To find the 20th term, we're going to do the same thing. A to the 25th, the 25th term is going to be equal to 3, times 2 raised to the 24th. So 2 to the 24th power, 2 to the 24th power is going to equal 16 million, sorry, I got to do the 3 times, my apologies, 3 times 16,777,216. So now I'll multiply by 3, and we end up with this being 50,331,648. That's what my 25th term will be equal to. And you can see that these are geometric because they're multiplicative. So each one gets bigger and bigger and bigger and bigger by doubling it essentially, or multiplying by 2. So now if I want to know the fourth term of this geometric sequence here, you can see that I'm multiplying here by 3. My first term is 4, my common ratio is 3, and if I want a sub 10, it's going to be equal to 4 times 3 to the 10 minus 1, which is 9. So I find 3 to the 9th power. So this is 4 times 19,683, and then I multiply it, and we end up with 78,732. Again, we have the same type of question for example 3, where we need to find the second and third terms. In this case, we are going to have, again, 3 common ratios. So remember, these are multiplicative. Our first term is going to be 2. We do not know what r equals. It's a question mark. But we do know what a sub 4 is. A sub 4 is negative 54. So I'm going to set this up. A sub 4 should be equal to my common rate, or to my first term times my common ratio to the 4 minus 1. Well, I know what a sub 4 is. It's 54, or negative 54. A sub 1 is 2. My common ratio is unknown. Oops, I don't know why I put 2 equal signs. My common ratio is unknown, but it's raised to the 3rd power. From here, we just do some math, which is algebra. We need to divide both sides by 2. We end up with negative 27. Negative 27 is equal to r cubed. To get rid of a cube, we need to use the cube root, and we end up with negative 3 will be equal to r. So, we can find the next few terms here if we just say, hey, we have to multiply by negative 3, so times negative 3 times negative 3 times negative 3. So 2 times negative 3 is negative 6. Negative 6 times negative 3 is positive 18. And you can see it goes back and forth between positive and negatives. I hope that this video covers all of the things that you need to know for arithmetic and geometric sequences. If you have any questions, please feel free to reach out to me. Have a great day.